Section 6.3, arcs and angles. So we're going to take a look at some conjectures of arcs and angles. And the first one we've talked about a little bit already, the inscribed angle conjecture. Now, in the diagram, you see we have a circle, O. We have central angle, ROY. And central angle, ROY, would have an intercepted arc of RY. Now, let's label RY. It has a measure of 95 degrees. Since that arc has a measure of 95 degrees, we know by the definition of arc measure that its central angle has the same measure. And if we were to take out a protractor and measure the inscribed angle, RXY, that's an inscribed angle because its vertex is on the circle, and the sides of the angle are chords of the circle, right? Well, notice that inscribed angle RXY has the same intercepted arc, RY. But there's no way that that inscribed angle measures 95 degrees. If we took a protractor and we measured that inscribed angle, it would always come out to be half the measure of the arc. So in this case, 47.5 degrees, half of 95. This leads to the conjecture, the measure of an angle inscribed in a circle is half the measure of its intercepted arc. Next is the inscribed angles intercepting arcs conjecture. Some of these names are lengthy. Remember, if you can't remember a name of a conjecture or a theorem, you can always just write out what the conjecture or theorem states, and that'll be fine as a justification. Now, we can complete this conjecture just by looking at our diagram. We have a circle, and we have two inscribed angles. The first inscribed angle is angle QPB. And it has an intercepted arc of QB. There it is. Our second inscribed angle is angle QAB, and it has an intercepted arc of QB, the exact same intercepted arc. So what do you conclude about the measures of these two inscribed angles? These two arcs are congruent. The conjecture states inscribed angles that intercept the same arc are congruent. Next one, angles inscribed in a semicircle conjecture. We have a diagram with a circle and three inscribed angles. We also have diameter AB, which makes this arc a semicircle. We know the measure of a semicircle is 180 degrees. Our three inscribed angles, one, has that semicircle as its intercepted arc. Two, has that semicircle as its intercepted arc. Three, has that semicircle as the intercepted arc, right? And we know that the measure of an inscribed angle is always half the measure of its intercepted arc. So each of these inscribed angles measures 90 degrees. So the conjecture states angles inscribed in a semicircle are right angles. All right, next we have a definition. A quadrilateral inscribed in a circle is called a cyclic quadrilateral. Each of its angles is inscribed in the circle, and each of its sides is a chord of the circle. The note at the bottom says the opposite angles of a cyclic quadrilateral are supplementary. So let's just sort of investigate this a little bit, right? We have inscribed angle 1 and inscribed angle 2. Inscribed angle 1 has this intercepting arc. Inscribed angle 2 has this intercepted arc. Now, don't assume that those arcs are semicircles. They look like they could be in this diagram, but they certainly don't have to be. We could draw a very different diagram that shows that they definitely are not semicircles, right? Okay. But there's no doubt that the combination of those two arcs are the entire circle, right? Which is 360 degrees. So if angle 1 is half the measure of its intercepting arc, and angle 2 is half the measure of its intercepting arc, and together the two intercepting arcs add up to 360, well then together the two inscribed angles have to add up to half of that, which is 180, which makes them supplementary. Here we define secant. A line that intersects a circle in 2 points is called a secant. The second statement here is to show the difference between a secant and a tangent. A secant contains a chord of the circle and passes through the interior of a circle, while a tangent line does not. Obviously, we remember that a tangent line touches a circle at one point only, right? We can see very clearly that a secant touches at 2. And then a final note that a secant is a line while a chord is a segment. And this is really just a reminder to use vocabulary carefully and correctly. Finally, parallel lines intercept congruent arcs on a circle. The congruent intercepted arcs are the arcs between the parallel lines, not the arcs on the outside. This diagram looks like the arc above and below the parallel lines could be congruent, but of course we could draw an extreme diagram where our parallel lines are shifted up, and obviously those arcs are not congruent. It's the intercepted arcs that lie between the parallel lines that are congruent.